So GENIE is the first real-time implementation of the all-hat navigation and guidance software. We've been working for about 5 years doing trade studies on what kind of algorithms do you need to process the data from the sensors you need, which is the main purpose of all hats, to really find out what sensor technology you need to do a safe precision landing at the moon. We have taken those algorithms kind of out of an analysis world, where we've been using the fake environment, an imaginary moon, and we put them in where instead of having nice clean data, they're getting noisy, bumpy data arriving whenever it arrives. So the big jump is making sure you can handle the real world. So that's the main thing we're testing. What's going on in parallel, all hats testing the sensors, semi-independent from the algorithms. And we look to converge sometime late fall, early next spring, and bring those two together. So this is going to demonstrate our capability to do high rate inertial navigation and to run what's called the Kalman filter to bring in more sophisticated data. If both of those work, then we can easily scale that up to the full-fledged sensors we're going to use.
So I'm Tye Brady from Draper Laboratory, and we're working with Tim with Johnson Space Center, and we prototyped this guidance and navigation solution working with JSC on it. It's something we're proud of, that we built the entire stack, which you see probably right about there. We did that in 7 weeks. So we're definitely a company that prides ourselves in prototyping and doing what we consider hard problems, the fun problems to do. And it's great to be out here on the field and see the prototype kind of come to life. And it was a success in that my first mark is does the whole thing even stay together. And it's good to see it in one piece. We're doing a checkout right now. My analysts are over there taking a look at the data and seeing what we got from the flight. That's bonus. We know that the system is operating as it did before the flight, so it tells us that mechanically everything's intact. Our mechanical structure to hold all our sensors are good. We think we're confident now to go for free flight. We had seen the vibration and the shock that we expect in the environment. We've learned the value of real field testing. You know, for example, our laptop that was sitting out in our truck in 170-degree heat out there started to get really hot. Started to slow it down. Got to cool it down, get all that ready. That's not something that we anticipated in the lab, nice air-conditioned lab. So this real field testing is good so that we can do these advanced prototyping type of activities. This is what engineers like to do. We like to build stuff. We love to be out here. I'm sweating, having a great time. The team's having a great time, and we're having a blast with this. Great. So just really good stuff. We should do more of it.
So we've got 3 sensors on board. We have a GPS, which is our truth sensor. That's what we're going to use to compare the results from the rest of the system to. We won't have GPS at the moon. We get it for free here. We also have on the far side of the vehicle a laser altimeter. It fires a near-infrared laser beam. It hits whatever's in front of it and comes back. A little clock measures the time difference between the firing and the receiving, divides by the speed of light, and says that's how far away whatever in front of you is. So that's one of the things we will have at the moon. Then we also have in the middle of the GENIE, there's this thing that looks like a coffee can, and that's a inertial measurement unit. It measures accelerations in 3 axes. It also measures rotations. So when we put the GENIE out on the pad, the first thing we did is we turned it on. The inertial measurement unit is sensitive enough that it could actually sense the rotation of the Earth. So it knew which way the North Pole was, basically. It could also sense gravity. Based on those two, the software we have on board would figure out which way is it pointing. From that point on, we didn't need to talk to GENIE again. It would integrate the GPS, the laser altimeter, and the IMU, and it just kept track of its position and orientation.